I'm Victor Morgante. My business is called FactEngine, and I make productivity tools for knowledge graphs. So my main product is a product called Boston, which is a conceptual modeling tool for defining database and schema structures, and FactEngine, which allows you to do controlled natural language queries over databases. So I don't have many slides. What I'd like to do is go straight into the software and show you what the software does. So just let me know if that's switched over to Boston. Can you see that, Daniel?
It hasn't switched over yet. You might have to stop your share and reshare.
Oh, I see. Okay. How's that?
Bingo.
Great. Okay, well, this is Boston. So Boston's a productivity tool for working with databases. It lets you do conceptual modeling and in cooperation with FactEngine allows you to do natural language queries over your database. The central thesis behind Boston is that it allows you to visualize your database as a property graph schema. So we've got a property graph schema here in front of us, or a entity relationship diagram. And the main modeling language used to create all of the models in Boston is object role modeling. The schema that we see before us is for a seat booking database for a cinema and some attribution. The original model for this schema was shared under the Active Fact projects on GitHub by Data Constellation. So you can imagine a database where seats are booked for sessions to watch films at a cinema, and the booking is for a person, and where a person can like a film with a rating, and where seats are in rows in that cinema and seats are in sections. So one of the defining features of Boston is that once you're in one particular view of the model, you can morph to the other view. So basically, it allows you to visualize practically any database as if it were a multi-model database. So now we're looking at the entity relationship diagram for that particular schema, and we can morph from that to the object role model as well. So the central thesis is that you can visualize practically any database as an object role model, property graph schema, or entity relationship diagram. The central focus is on object role modeling, and object role modeling, I'd like to go backwards before we go forwards because object role modeling might be new to some of you, is a type of conceptual modeling that works on fact types, and where a fact type is defined as a set of roles. And if we define a fact type, person likes film, that's a fact type with two roles, where person plays the role of liker and film plays the role of liked film. You don't have to have role names in object role modeling, but those of you who are familiar with TypeDB, that'd be very familiar to you, where the relation person likes film relates liker to liked film, where person plays the role of liker and film plays the role of liked film. As a relation, person likes film is reified in this particular relation as person likes film, and where that reified relation has a rating. So we can say person likes film with a rating. We've also got another relation off here to the side, or fact type, where film has name. So those familiar with TypeDB would recognize that as an owns relationship, where name becomes an attribute for an entity film. So film owns effectively the film's name. Now, just a brief history lesson on object role modeling before we go forward. Object role modeling was initially defined as NIAM as the output of the PhD thesis of Terry Halpin. And what Terry Halpin did was map a morphism between the diagrams of an object role model and theorems of a theory under finite model theory called KL, or knowledge language. So that's the history of object role modeling. It's got deep roots in logic, and object role modeling has, to some degree, moved forward a little bit from those days, where there are some constraints in object role modeling which today require software to disambiguate a diagram. So this is an object role model of the complete schema, and I'll just click on this subset join constraint in the middle here. If I can direct your attention down to the bottom of the page, what that subset join constraint says is if some booking has some seat, then that booking is for some session that is at some cinema that contains some row that contains that seat. And if we go to the property graph schema, what we're saying is that if a seat has a booking, you'd want to make sure that the seat has a booking for a session that's at a cinema where the seat is in a row that's in that same cinema. Now, if I go back to the object role model and click on it, you can see the role path taken in the two different colors there, blue and purple, where the blue is if some booking has some seat, and the purple is that booking is for some session that is at some cinema that contains some row that contains that seat. Without diving too much into the theory, you can see here there's another path that could have been taken where a row is promoted in a cinema, or a cinema promotes a row. And modern day object role modeling since around 2005, you couldn't just look at this diagram and disambiguate it to say that it took the cinema is in row path rather than the other path without software to help you. So that's where tools like Boston come in. So Boston allows you to do your object role model in software and disambiguate the diagram to ratify the schema. So because object role modeling at its core uses predicates such as person likes film, and where those predicates can transpose right across to the property graph schema view, or even the predicates that are on the relations in a Barker ER view, object role modeling lends itself very, very readily to having the ability to query your database in natural language. So this particular schema is hooked up to a database in the back end. And if I open FactEngine now, FactEngine lets you write controlled natural language queries against your database. So we could say something along the lines of which seat has a booking that is for a session that is for the film Rocky, that is showing at cinema, Great Western Cinema, and you can see it's going away to the database there to help us complete the query on date, time, and I know that I can go and see Rocky on the 1st of the 5th, well in the past now, but 1st of the 5th, 2021 at 10 AM. So that's how easy it is to write a query in FactEngine. I'll just hit F5 on that and hit go, and you can see it's come back with a result. So seat 1A in the Great Western Cinema has a booking to watch the film Rocky. Now I can extend that query by saying, and that booking is for which person, and hit go on that, and we can see in the results that that booking is for Peter. So this particular database is against the relational database, and we'll get to TypeDB very quickly. And you can see that the query's been converted into SQL for that query. Now, I'd like to move on to an aspect of FactEngine and which relates directly to TypeDB, but we'll explore it first on a relational database, and then we'll move over to TypeDB. So I've opened a query: which seat is in Cinema, Great Western Cinema, and has no booking, that is for a session that is for the film Rocky that is showing on that particular date and time. So basically we're asking which seat is available for me to make a booking. So I'll just hit go on that, and it's come back with 3 seats, so 1B, 1C, and 20A in the Great Western Cinema. Now that particular query is interesting for us because it starts off by saying which seat is in Cinema, Great Western Cinema. Now if we look back to our model, we don't know that seats are in cinemas. We know that a seat is in a row, and a row is in a cinema in the schema for our database. So how did FactEngine know that those seats were available in that cinema? And that's where we get to what TypeDB does very well, and that's the implementation of rules. And I'll just make that a bit bigger so you can see it. And object role modeling supports rules as well. So where seat is in cinema, and the rule behind that is seat is in cinema is where seat is in a row that is in cinema. So when we execute the query, which seat is in Cinema, Great Western Cinema, if I can execute that query, FactEngine and Boston will go away and execute the rule for that particular derived fact type they're called in object role modeling. So seat is in cinema there is a subquery within our overall query. And then when we extend our query and say and has no booking, that is for a session that is for the film Rocky that is showing on that date time, we're implementing negation. And when we hit go on that, not only have we implemented that rule, we've also implemented negation and the overall query. We can simplify the query a lot more by saying which seat is available at the cinema, Great Western Cinema, to watch the film Rocky at date time. Execute that, and we get the same 3 rows back. Now, the way I've done that is by creating another derived fact type called seat availability, and where that is a rule that's implemented within the database as well, where seat is available at cinema to watch film, whatever film you choose, at a particular date time. So when we go back to our query and hit go, it's not only implemented the seat is in cinema rule, but a further rule, seat availability. Hopefully you can see that on your screen, and join those together to make one mother of all SQL queries. So TypeDB has been created to get away from having extremely long SQL queries. So I think we can move straight away now to TypeDB. So I've got a model open in Boston here, the social network model, which is a schema that's implemented on TypeDB and is supplied by Vatical from their website. Now, I'll show you in the background, I don't know if you can see, probably not, that I've got TypeDB open. So the TypeDB server is running in the background, and this schema is hooked up to that database. Now I'll open a very simple page in that model and try and make that a bit bigger so you can see it. And we'll look at some of the concepts in TypeDB that relate directly to object role modeling. So a person entity in our TypeDB database, and in object role modeling, you can have whatever predicate you like. So I've got has, but you'd recognize that in TypeDB, these would be owns relationships, where person owns phone number, full name, nickname, gender, and whether they're unemployed and graduated. And object role modeling doesn't have the concept of attributes. Everything is defined as fact types, where attributes are defined ostensibly as a fact type between an entity and a value type. But there is a direct correlation with an owns relationship in TypeDB. We can also see here we've got a relation called fluency, where person fluently speaks language is under the relation fluency, which relates speaker and language, where person plays the role of speaker and language plays the role of language in the relation fluency. So object role modeling has practically a one-to-one correspondence with TypeDB and TypeQL, and that goes as far as having subtypes, and even object role modeling does support the concept of relations being subtypes of other relations, but that particular aspect isn't implemented in Boston at this stage. Subtypes of entities being subtypes of other entity types is supported in Boston. Now, if we go back to FactEngine, and just give me a second while I bring up another query. So we can ask then, which person fluently speaks? Okay, I've got a problem with my session. Just forgive me while I close TypeDB and open it again and see if that fixes the problem. You there, Daniel? I'm having troubles getting back to Boston on the screen share.
Are you seeing it in the options in the screen share?
No. Let me just try something and then I'll...
You can also share your desktop.
Oh, hold on. New share. Here we go. Let's get back to Boston. Sorry about that.
Yep.
Can you see Boston in front of you now?
Looking good.
Yep. So I should still have that query there in front of me. Okay. So we can ask which person fluently speaks language English and has which phone number. So we're looking at the relation fluency, where person fluently speaks language, and where person owns a phone number or has a phone number. So we'll hit go on that, and it's come back and given us all the people in the database and their phone number. Now, here's the TypeQL query now rather than SQL behind that query. So Boston has, or FactEngine has converted that to TypeQL. So the idea behind FactEngine is that regardless of the type of database behind FactEngine, you should be able to write your natural language queries in one language and have that translated to the query language of the database. So just bring up a more complex query. So where we're saying which student went to school UPL with student 2, Tanya Arnold, and that student did which course, and that student 2, which is Tanya Arnold, did which course 2, and that student 2, which is Tanya Arnold, fluently speaks which language. So why you would ask that question, I don't know, but it's an example of a complex query. So Rafael Santos went to school UPL, did accounting, and Tanya Arnold speaks English, and she did accounting as well. So there's the TypeDB query behind that. You can use Boston as a client for TypeDB and actually type your TypeQL queries into Boston, but I'd rather do it in natural language. So that's quite a complex query. You can see in TypeQL that'd be quite verbose to write out that query, and part of the reason, or a big part of the reason for FactEngine's existence was to be able to write queries that not only easy to write, but easy to understand and reverse engineer so that you understand what the query is about. So what I'd like to do now is just go through a few more queries where we can focus on the strengths of TypeDB. Now, this query here, which person mutually traveled with a person 2 at which location, and that person 2 has gender male. So who traveled somewhere with a male person? We'll execute that, and we can see that Sophia, Miriam, and Julie traveled to Holsworthy, French Lick, and Fairmont with these males, Fabian, Solomon, and Jeremy. And there's the query behind that. What that particular query has used is effectively a derived fact type inside TypeDB, where I'll just make that a bit bigger so you can see it, where TypeDB implements rules directly in the database itself. So rather than the SQL example where the SQL had to contain the rule, this rule here on the right-hand side is actually implemented within the schema within the database, and our query only need reference the relation mutual travel to return results for that particular rule. And what that rule says is that if 2 people traveled to the same location and those 2 people aren't the same person, then that's called mutual travel. And if we look at the TypeQL query that was executed, we can see where mutual travel has been called in our TypeQL query. So the TypeQL queries compared to SQL are certainly a lot less verbose because the rules are implemented inside the database itself. So let's have a look at a few more examples along that line. This particular query doesn't use a rule, but it's an interesting query nonetheless, and gives you an example of the type of things you can do with FactEngine. It says, person Solomon Tran requested to be friends which person 2, and that friend request has which approved date. What you'll notice about that query is not only has it referenced the relation itself, so person requested to be friends another person, but it then references the reified friend request to get its approved date. So let's have a look at friend request as an object role model, and we'll understand that. So friend request is where a person requested to be friends another person as requester and respondent, and where the reified relation then has an approved date. So when somebody approves the friendship, it gets an approved date. So that's been executed. So Solomon Tran requested Julie Hutchison and Leona to be friends, and that's the date they accepted that friend request. So that's looking at reification inside FactEngine. Now, the critics among you will be asking already, well, how do you do things like negation? So let's have a look at that. So which person is employed at no organisation, and that person has which phone number? So basically, we want the phone number of people who aren't employed. So execute that, and it says Halima and Jeremy. If we look at the TypeDB query, we can see that we've got a sub-query inside curly braces, and we've got a not in front of that. And that sub-query is over the relation employment, such that what we're saying is, give me the people who are not employed. So when we execute that, I should be able to execute that from there, no? We get Halima and Jeremy, and they're not employed, and that's their phone numbers. So that's negation inside FactEngine. Now, TypeQL supports, I'd say, the full range of comparators. So let's have a look at the like comparator. When I have a tilde here rather than a colon, what I'm saying is which person has a full name like Tanya.star. TypeDB uses regular expressions, so we're saying which person has a full name that starts with Tanya. And we've got Tanya Arnold, and we can go to the TypeQL, and you can see that I've used the like comparator and the regular expression Tanya.star, so whose name starts with Tanya. Tanya Arnold's name starts with Tanya. Now, just to show a little bit more of a more complex query, which person has full name? Now, this regular expression says doesn't start with Tanya. So that'll give me everybody else in the database. And that's used the like comparator again, and a bit of a tricky regular expression, which basically says which person's full name does not start with Tanya. So that's the like comparator. Of course, we want to be able to say not equal to. So if we say which person has a full name, and the exclamation mark is in FactEngine is not equal to Tanya Arnold, and that'll give us a list of everybody else in the database as well. If we go to the TypeQL, that's translated into not equal. So FactEngine supports a range of comparators that you'd expect to see in a query language. Also, you can do simple mathematics in a FactEngine. So which school has a ranking greater than 50 and has which course? And so these schools have these rankings greater than 50, and that's the different courses that are available in that school. So that's simple mathematics in FactEngine. I'd like to show you another implementation of querying rules or inference rules inside TypeDB. Now this query says which organization owns which office and hires which employee that has a mutual profession with employee 2 Sophia Baker. I'll show you the object role model for that first, and then we'll come back and do the query. So we have a relation called employment, where organization hires an employee in profession, and we have a rule that's inside TypeDB where we're saying if two people are hired in the same profession and they're not the same person, then that's a mutual profession. So that when we go back to our query, we can ask questions like which organization owns which office and hires which employee that has a mutual profession with employee 2 Sophia Baker. So we'll hit go on that. So Julie, Miriam, and Fabian work for organization 1 that has an office 1. So we can extend that, and we can say in which profession. And we can see here they're all bioengineers. So I'll just do one more query. And then I think we've got a pretty good feel for how FactEngine works over TypeDB. So this is a very simple query. Which person is in a romantic relationship with which person too? And that romantic relationship, so once again, we're referencing the reified relationship, has which start date. And these people, so Halima and Sophia, etc., in a romantic relationship, and that's the start date of the romantic relationship. So that's a brief overview of the core thesis of FactEngine and Boston. So just to recap, so Boston allows you to view your database as a property graph schema or a entity relationship diagram or a object role model. And because object role modeling is, I would argue, the most semantically verbose conceptual modeling language on earth, this allows you to then write queries in controlled natural language against the database. So our social network database in TypeDB can be viewed as an object role model, as an entity relationship diagram, or as an object role model, or as a property graph schema. So that might come in handy for people. So that's the first half of this presentation. The other half was to show how Boston can be used to generate database definition language for the schema for a TypeDB database. So let's pick on our cinema bookings schema once again. So if I go to that and right click on it, I can open the code generator. So Boston has an inbuilt code generator which is template driven, and this is a template for TypeDB. There's not much code there. There doesn't really need to be because the correlation between object role modeling and TypeDB is quite close. We nominate a source. So the working model is cinema bookings. There's a set of transformations which transform data types from object role modeling or from Boston into the data types of TypeDB in this case. So that's mapping the types of attributes to the types that are in TypeDB. We've got our template. We just hit build on that, and that's finished already. And we'll open that. I'll maximize it. Can you see that, or do I need to screen share it?
It looks good.
You can see the define statement. Hold on. I'll share that. Can you see the define statement there?
There we go.
Yeah, okay. So that's the define statement that's been created for the cinema bookings schema. So originally that was over a relational database. We've just converted it into a define statement for TypeDB. And we can see where cinema is a type of entity, and we've got a key on that, and where cinema plays those roles in those relations. Similarly for film. Now, I'll scroll down on this and show you some aspects where you just need to make a few modifications possibly. So booking, in the middle of the screen, I'll highlight that, has the attributes that have come across from the entity relationship diagram inside Boston. You might not want to store those particular attributes. You'll also notice that because all of those form part of the primary key inside Boston, they've all come across as key in the define statement. TypeDB only supports one key on a entity or relation, as far as I know. So what you would do is just take those out. So booking owns a seat count and relates person booking and session booking. Now, the role names in this example have been predominantly created by Boston. So you don't have to define role names for every single relation in your schema before converting it to a TypeDB schema. Boston will do that for you. Having said that, if you remember our person likes film example, and I'll go to the top there and highlight that, it's taken across the role names that we had defined, so liker and liked film. So that's entities and relations. There's a bit of white space there. You probably just need to tidy up. That's not really a big deal. And then, of course, there's our attributes with their data types in the TypeDB data types. This particular template will put an attribute twice in there. You can just remove any duplicates. I don't think TypeDB has a problem with duplicates in a defined statement, but if cinema ID is defined twice, just remove any duplicates. And then right at the end of this, there'll be another three relations down the bottom. And it's as simple as that. So you can use Boston to generate your TypeDB schema and create your TypeDB database. If any of the entity types were a subtype of another entity type, or entity as they're called in TypeDB, that would show up here. If, say, you had movie was a subtype of film, you'd have movie sub-film, for example. The only thing is that Boston doesn't support relations as subtypes of other relations. And that pretty much wraps up my presentation, Daniel.
Thank you so much, Victor. Oops, I'm going to keep myself off here for the recording's sake. So we are able to sort of model a live meetup experience where you can come off of mute and share questions or feedbacks with Victor and the rest of the group, and you can do that by raising your hand. We do have a question from Michael in the Q&A, so we'll start there. Michael asks, which property graph DBs do you currently support querying against?
So no graph databases at this point in time. So FactEngine could be implemented over graph databases. At this stage, I've decided to stick with relational databases and TypeDB.
And I've got a quick one. So you sort of talked through some of a lot of the functionality here. What do you see as a potential use case for FactEngine and those that are building with TypeDB?
Well, TypeDB is targeted squarely at knowledge graphs, and quite large knowledge graphs. So, for instance, Boston supports reverse engineering of TypeDB databases now. So I've reverse engineered the bio-COVID database that's been created by Vatical, and it's quite a large database that you could classify as a knowledge graph, and it's a productivity tool for being able to, FactEngine at least is a productivity tool for being able to query quite easily a knowledge graph.
And what's the best way for those in attendance or those watching to get in touch with you, either to collaborate or to provide feedback? Sort of what are you looking for from the community?
Oh, okay. Well, first of all, thank you very much to the community for helping me to get this far in helping to integrate Boston and FactEngine with TypeDB. So I'm happy to help out. There is a student version of Boston available, which isn't as expensive as the professional version. I'm happy to collaborate with people on their knowledge graphs to help them get up and going with Boston and FactEngine.
And Victor, as we mentioned before, at the very beginning, Victor is extremely engaged on our Discord server. That would be a great place to connect with him and ask any questions that you might have. Enrico dropped, excuse me, Enrico dropped a couple questions into the Q&A. The first, do you allow for some type of denormalization when generating the database schema?
When Boston creates a entity relationship diagram and by default a property graph schema, it follows the original rules as set out in Halpin's PhD thesis and in subsequent publications. The short answer is no. So what you see is what you get, basically. You can add extra attributes to entities inside the entity relationship diagram view. What I would argue is that with object role modeling, I think, as you'd know, Enrico, you can structure your object role model to get pretty much any model that you want. So you can forward engineer the model you want, I believe, just by using object role modeling itself.
And what was the name of the knowledge graph you mentioned just a few minutes ago?
Oh, bio-COVID. So TypeDB has released quite a sizable schema for doing research on COVID patents and it's patents that relate one way or the other to research on viruses and as they relate to COVID.
And I've just dropped in the link to the GitHub repo to BioRec and COVID there, Beto, so you can check that out. Thank you for those questions. So Michael asks, is ORM fifth normal form?
When object role modeling transposes across to an entity relationship diagram, it adopts third normal form. That's the short answer on that.
Okay. I know I'm not sure if you and Michael have connected on Discord yet, but I know you two would, I'm sure, find many things to go back and forth about. So I hope you guys connect on Discord. And for the rest, Enrico says it's actually 6 normal form. Interesting. Enrico,
well, object role modeling itself is 6 normal form. When it transposes across to entity relationship diagrams, you'd say it was transposed into third normal form. But object role modeling itself is in very fine detail. So you would say 6 normal form. Yeah.
Right. Okay. Thank you. Yes, correct, Victor. I appreciate those. I appreciate the questions. Enrico, Beto, the rest of everyone in attendance, still do encourage you to join Discord. We can sort of continue the conversation there, as there tend to be a lot of questions that come up after things get going. And it's a great place for everybody to reconnect coming out of the event. As I mentioned, this recording will be up on YouTube tomorrow, or actually up on YouTube on Thursday, and then you'll be able to check that out on demand. Victor, any parting words for the group before we let them off?
Well, thank you very much for attending, and thanks once again to all the staff at Vatical for helping to get this presentation up and away. I really appreciate it.